Hello further students. Now, last time I tried this it was a 17-minute video, so I'm going to do the same thing but much more quickly now. Alright, so to deseasonalize data from raw data takes several steps. Firstly, we need to calculate the seasonal indices. Seasonal indices come first, and we do this by saying a seasonal index is equal to the value for the season divided by the seasonal average. So in terms of years, we would do the value for the quarter or the month divided by the average for each quarter or each month of that year. Over multiple years, we may need to average if necessary, and we'll see that below. Now, then, after we've discovered or calculated the seasonal indices, use the seasonal index to deseasonalize individual data points. Then, once we've deseasonalized the data, we can plot it, compare it to the original, add trend line, draw conclusions, etc. Now, typically you won't be asked to do the entire thing in an exam. You might just be asked to fill in a couple of steps, but it's important you understand the entire process because it can be given to you in SACs. Alright, so our question is, calculate the seasonal index for each quarter, use the seasonal indices to deseasonalize the data, correct to decimal places, plot the original and the deseasonalized data on the same axis. This here is the raw data. It shows sales for each quarter for 3 years. Quarter 1, quarter 1, quarter 1 of those separate years. Firstly, we calculate the mean of each year. So the mean of each year, we add along here, then divide by 4. So this is adding along here divided by 4. The mean of the first year is 6, and so on. And you can sort of guess that we're kind of going up. Mean of 6, mean of a bit more than 6, mean of 7. We're expecting the averages to increase. So this is forecasting a growing trend in the end. Then, we calculate the seasonal index for each quarter by dividing each quarter by their mean of that year. Alright, so the seasonal index of each quarter for year 1 is the original of quarter 1, year 1, divided by the average of that year. So it's the original here divided by the average of that year. Original divided by average, original divided by average, original divided by average, etc. And this indicates how good the quarter was for the year. So that was half of the quarterly average, that was 1.5 times the quarterly average, etc. Now what this gives us is quarterly seasonal indices for each quarter. See those three there? What we do now to find the seasonal index for quarter 1 is average them. So the seasonal index for quarter 1 is 0.83, 0.64, 0.68, 0.83, 0.64, 0.68, total together divided by 3. That is the seasonal index for quarter 1. So on with the others. We find the quarterly indexes for each second quarter, average them to find the overall, and so on. And what this shows here is that quarter 1 is typically lower, quarter 2 is typically higher than the average. Alright, and there's a table summarizing it. That is part A. We have the seasonal indices. So a typical statement would be that quarter 3 is typically the most successful statement with 43.98% more sales than the average quarter. Alright, now we need to deseasonalize each point. To deseasonalize each point, we take the actual figure divided by the seasonal index for that point. So for example here, our first data point was 5. We're going to take that 5 and divide it by the seasonal index for that quarter. Seasonal index for that quarter is 0.72, so we do 5 divided by 0.72, and this here, that 6.94, is the deseasonalized figure for that quarter, and so on. 7 divided by the seasonal index for quarter 2, so seasonal index for quarter 2, 7 was the original, we get the deseasonalized figure, and this continues on. Right. Now we can plot it. So on the calculator, we have a time with 1, 2, 3, 4 to 12. The original data points are 5 and 7 to start, and so on. And then the deseasonalized data points. Alright. On the plot, this is time versus the original. Now, if you want to... Now, seeing a pattern there is insane. I mean, what's even happening there? Typically, a line is plotted between the two of them. So you can go menu, plot type, plot properties, connect data points. And you can see that it's seasonal. Peaking in 3, dipping to 4. Peaking in the third quarter, dipping in the fourth. Peaking in the third quarter, dipping in the fourth. But we're unsure of a trend or what happens in each of the year. So we can go menu, plot properties, add a Y variable. We want to add the deseasonalized data in there. Now, deseasonalized data, it connects for us as well. And how cool is this? We can see that for the first year, there was a decreasing trend, and then for the second 2 years was a generally increasing trend. So we can see that by deseasonalizing the data, we can talk about each year in more sensible terms. So even though the original data is going up and down hugely, the deseasonalized data shows us what's actually happening irrespective of the seasons. Alright, hopefully that one was shorter. Thank you very much.